All right, so when we're talking about financial math, we often also discuss inflation. And this is something that you'll study in economics class if you take that. But inflation is the general increase in the prices of goods, so things that you buy, or services, things that you pay people or companies to do for you over time. So your parents, probably not your parents actually, my parents, often talk about how much less expensive things were when they were kids. So my dad would say that he used to work at a gas station and he worked really, really hard and he made like $2 an hour. But he only made $2 an hour, which sounds crazy now. But you could go down the street and buy a pop and a bag of chips for 10 cents. So things have increased steadily over time. And that's really, really normal. Things get more expensive as time passes. What that means is that your money, if you just took the amount of savings that you had in 1980 when you retired, for example, you're an old person, you retire in 1980, you're still kicking today, that money that you had is going to be worth way less. So maybe back in 1980, it was recommended that you have $25,000 saved away to have a nice retirement. Now it's probably recommended that you have closer to $1 million at least saved away to have a nice retirement. So $25,000 doesn't stretch nearly as far now as it did in 1980. And what that is inflation. Things cost more as time passes. So when you're making investments and looking at purchasing things in the future, you have to consider that your money is going to be worth less because things are going to cost more. So, an example 2, Simon wants to buy a car, and it's currently worth $5,000. He makes monthly deposits into an investment account, and he plans to buy that car 5 years down the road. If inflation averages 2.5% per year, calculate the value of the car index for inflation for 5 years. So we want to know how much that car is actually going to cost in 5 years' time. So all we do there for inflation is we take the current value, so we'll call this actual cost. So the current value of the car is $5,000. We multiply it by the rate of inflation. And we're going to do 1.025. So 2.5% is the same thing as 0.025, but it's actually going to cost 100% of its current cost and another 2.5% on top of that. So we're multiplying that by 1.025. We would say this is the index to the power of however many years we're looking. So we're looking 5 years down the road. So 5,000 times 1.025 to the power of 5. And what that gives me is a future price of $5,657.04. So that's how much that car is actually going to be worth in 5 years. So Simon is going to have to update his monthly deposits in order to reflect that actual future value of the vehicle. We can also consider final values of investments that we're making now. And we call that real values of investments. So let's say Abby invested $4,000 in an account for 5 years. She's earning 4.8% interest per annum, and it's compounded half yearly. So that means twice a year. Inflation over that period, over those 5 years, averaged at 3% per year. So without considering inflation, let's calculate the value of the investment after 5 years. So we're going to use the formula listed above. Our future value is going to equal our present value, $4,000, times 1 plus 4.8, our investment amount, divided by 100 times the number of compounding periods in a year, which is 2, to the power of 5, number of years, times the number of compounding periods per year. So 5 times 2. So simplifying that a little bit so we can plug it into our calculator, we end up with 4,000 times 1 plus 4.8 over 200 to the power of 10. And we end up with a future value of $5,070.60. So that's how much that investment would be worth today. However, we're looking at kind of capitalizing on that investment 5 years down the road. And 5 years down the road, that investment is going to be worth less because of inflation. And we know that inflation over the period averaged at 3% per year. So in order to find what we call the real value of that investment, we need to take the projected future value, $5,070.60, and divide it by 1.03. So our index, to the power of the number of years out we are. So we're 5 years out. And when we divide that, we end up with $4,373.95, which is going to be the real value of that investment 5 years down the road, which doesn't seem like she's made